This is our next example. We have limit as x approaches 4, x over x minus 4. And this is the special limit type. I have here the 4 possible scenarios that are on offer. Just you don't need to have those. This is just to sort of illustrate what's happening. To see, we need to find out which of those 4 scenarios is here. Recall, if it's this scenario, then what we're going to say is the limit is positive infinity. If it is this scenario, we're going to say the limit is negative infinity. If it is either of these two scenarios, then we're going to say the limit does not exist, because the limit from the left, the limit from the right do not agree. The limit from the left, the limit from the right do not agree. So that's our procedure. All right, first thing we try, as always, the first thing to try is direct substitution. Well, direct substitution gives us 4 divide by 0. So that lets us know we need to make the special note. Direct substitution produces 4 over 4 minus 4, which is 4 over 0. This is our special case. And we're going to choose, we will use x is approaching 4. All right, here's 4. I need 1/10 on either side. 3.9, 4.1. So we're going to use x equals 3.9. We're going to use x equals 4.1. All right? All we need is positive, negative. We don't need to know the number. If you have the number, that's wonderful. But all we need to know is positive or negative. So, substituting 3.9 into x over x minus 4. So we have 3.9 over 3.9 minus 4. This gives us positive 3.9 minus 4 is a negative value. Positive divided by negative is negative. So we know from this we may conclude that the limit as x approaches 4 from the left, this is less than 4, of x over x minus 4, this goes to negative infinity. All right, negative infinity. Let me write that a little better here. All right. Same song, second stanza. For x equals 4.1, substitute 4.1 minus 4. And that gives us 4.1 is a positive number. 4.1 minus 4 is also a positive number. Positive divided by positive is positive infinity. So we have the limit x approaches 4 from the right goes to positive infinity. So as you approach from the left, it goes to negative infinity. So it's not this. As you approach from the left, it goes to negative infinity. It's not this. Right? As you approach from the left, it goes to negative infinity. As you approach from the right, it goes to positive infinity, which means it's not this. This is what we have. Notice the left-hand limits and the right-hand limits do not agree. The left-hand limits and the right-hand limits do not agree. The left-hand limits and the right-hand limits do not agree. So what we will say is this limit, the unrestricted limit does not exist. It's not actually right to say equals. This limit does not exist. Sometimes some textbooks will say has no value. Some textbooks will say there is no limit. The phrase I tend to use is does not exist, and that's pretty common. They all mean the same thing. This limit has no value. So this limit does not exist. So it's straightforward. Anytime you're in the non-zero divided by 0 case, non-zero divided by 0, go off to the side, check to see if you get what result you get. And then you choose, if you're in this special case, I need to see what's in this box, right? Work to the effect that you understand what's happening here. And then choose a value 1/10 less, 1/10 greater, and evaluate. All we need to know is positive, negative, in this case negative, which means this is negative infinity from the left. Substitute, we get positive over positive. This is positive. So this is positive infinity. As you approach from the right is positive infinity. And so since the left-hand limit and the right-hand limit do not agree, that means the unrestricted limit does not exist.